Hello YouTubers, and welcome to my channel and welcome to my mini solar generator project. This here is a mini solar generator that will be powered by a solar panel like this, portable solar panel that will provide 12 volt DC up to 400 watts AC, deliver 30 amps of current, and packs a little over a quarter of a kilowatt of total power. I had a great time putting together this project. It really wasn't that hard to do. I actually ran across these by accident. I was recently became a ham radio operator. One of the things I want to do is build a ham radio rig that I can keep at home, as well as take with me in my RV when I go to travel. And when I was researching those, I noticed that some of those people put batteries on their rigs, because sometimes ham radio operators also go to places they call field days, or they go to days in the park, or they go to other events where they need power on their rig. Now, I thought that was a great idea. However, most of the time, my rig is probably going to be plugged in at home. Second most will probably be in my RV. In both places, I do have power. However, for those occasions that I do go out to field days and such, having portable power is a must. So I thought it would be a great idea. However, I didn't want to just actually put it on the rig. And then I ran across YouTube where everybody was putting together these little solar generators. And I thought this was a great idea because not only could I make it to power my ham radio, but also it could provide power for my drones. I fly drones as well, and I'm constantly worrying about trying to keep the batteries charged so I can stay in the air and get footage. And so with this, I also use my tablets when I fly. And so I got to keep those charged up as well, plus other devices and such. So having portable power to be able to use for when I'm flying my drones, or if I'm at a tailgate party, or out camping, or just around the home in case the power goes out and I need to charge something. This little solar generator, this mini solar generator, I thought was a great idea and a great thing to do. Like I said, it wasn't very difficult to do. It was actually pretty easy. If you go on YouTube, you'll find a lot of people out there who put them together, and you can watch them. I want to say in particular, there was one person that probably inspired me the most by what they did, and his name is Joe Marquez, and I got a link to him in the subscription in the description down below. If you go there and look at his, he actually put together a unit that was actually smaller than this and packed up to over a quarter of a or half a kilowatt of power, and he did that with lithium ion, building his own battery bank. I thought that was a bit much for me to do on the first time. I am not an electrical engineer. I do know basic wiring. I'm basically a do-it-yourself type of guy, but I only have so much knowledge on that electrical stuff, and I didn't want to take the chance. So anyways, but he did a great job. There's a link in there. Go check it out and look at his stuff. This was a great project, like I said, easy to do, didn't take a whole lot of time, and but I hope that with you watching this, I'll go into how I put this together, and hope you enjoy it. And at the end, we'll get together and finish it up. All right, thank you. Okay, these are the parts that I'll be using to put together my project for my portable solar power generator. First thing I'll start off with here is the case I'll be using. It's an MTM 50 cal ammo box. And this here is a Mighty Max 12 volt 22 amp hour lead acid sealed battery. This battery here, I searched around. This is as far as sort of the amp hours I wanted. So this was the battery I found. And then when I found the battery, I looked for the case. I wanted to make sure that the battery fit the case and I had enough room to work with. You might be a little smaller depending on what you want to do, but this is going to fit my needs, so this is what I went with. The system's also going to be designed to deliver 30 amps of current in max, and that's primarily because a ham radio could draw up to 20 amps. And so this here 30 amp will protect the system in case anything over. This will go inline as a master breaker, and this here is a 30 amp on-off switch that will be able to kill the whole system with a little LED. This here is a coulometer. This coulometer is something that's going to give me voltage, feedback, amperage usage, and it's also going to tell me, how full the batteries are charged, how much time I have left even. So This is going to be really good for getting feedback on the entire system and what's going on. Back here, since this is a solar generator, you got to have a solar charge controller, and that's what I purchased here. This will also provide input from the solar panels or a power source, be able to charge the batteries, keep them topped off, as well as prevent over discharge, because batteries like to stay fully charged, and if they discharge too much, and or if they stay in a discharge state, it could ruin your batteries. And if you properly maintain and manage your batteries, this could last a very long time. Okay, here is a fuse box block that I'll be using. This here will give me, I believe, 6, control up to 6 devices. I have 5 that I'll be using, so I'll use 5 out of the 6. And this will be power distribution, positive, negative, bus bar in there. I'll use that. I'll be using some various switches in the system. Here will be a USB with a low and a high charge or fast charge, slow and fast charge output. So I'm putting 2 of those in there. That way it will allow me to charge up to 4 USB devices, phones, tablets, etc. This here is 12 volt plug that I'll be putting in. This will be something that will be able to put in like another charger for some other device. Also, it is going to use my inverter. When you have a solar generator, the idea is it could output 110 volt, and I will be using that. I'll show that in a second. I have this here is an Anderson power pole plug that I'm putting in. Ham radios use these a lot, so I'll be putting this in, and I'll make some cables. I'll be able to go from here and jump to my rig. I'm also going to put in here are some LEDs. I bought these. I'm going to put them on the front here, or maybe up here somewhere. But I saw that on somebody's build, and it was a pretty cool idea. That way this could be used as sort of like a big flashlight. Put that there. I'll be putting switches for everything in here. So these are, let me see, get on there, a little switch with LED. And I'll be putting one for each one of these, as well as the LEDs up here, so that it will be able to turn things on and off. One thing I'm also going to be putting on is since this is a solar power generator, we got to have input for the solar power. So what I'm going to do is put in one of these old plugs. You may have seen these. These are like the little 5.5, 2.1 millimeter DC input plugs, and that will allow me. I'll put it. I don't know. I'm going to put it up here, or maybe on the side. But here's a cable for the solar panel. It just has these. They'll go from the solar panel and plug right in. Here is the solar panel that I've got. It is a 65 watt solar panel. It does have a USB charge capability in here, so I could just use this, but it undoes and folds all out, I don't know, about 4.5 feet, maybe 5 feet. And I can put that in the back of my truck or hang it up somewhere and collect sun and be able to provide power to here to charge through that there. Okay. And like I said, it will use this cord to connect between them. Also, to charge this system, in case I'm not in sun, like inside the house, I bought this, which is a 110 that converts to 12 volt. Again, 5.5 by 2.1 millimeter, so it'll go in. This doesn't care as long as the power coming in is DC, right? 12 volts. And so either from the solar panel or that charger, you'll be able to charge your battery. Like I said, it wouldn't be a generator without 110 volt. And so what I do have is this 400 watt inverter that I'll be able to run, you know, some things off. It also has a little USB plug in there, but run a few things. And it runs off to 12 volt. So that's where this plug comes in. I can plug it in, and I can have 110 voltage as well, powering off of this. So anyways, these are all the parts that I had. I bought everything off of Amazon except for the inverter. I had the inverter for years. It was in my garage, and I used to just carry it around in my car, but I don't really use it much anymore for that, so I'm going to repurpose it for the solar panel, and that's what I'm going to start with. So those are all the pieces. The parts list is on the posting. It says I purchased everything from Amazon. They came pretty quick, so I could do it. So with that, the next step I'm going to go to is I'm going to drill and mount all the switches and get everything set up, and then before I go to wire it. So that's what's going to be. So with that, I'll be right back. Okay, we're back, and I have drilled and mounted all the hardware. So you notice these were all the components that we looked in the last clip, and I drilled and mounted them in here. Here's an on and off switch. It's going to be here. A switch here for the LEDs. These switches are going to power these different sockets. Put the meter in. Look in the front here. There's the LEDs. And everything's in there. For you to be able to do this, obviously you're going to need a drill and some different sized bits. I have a 1/8, a quarter, a 3/8, a 3/4, and an 1 1/8. I use this 1/8 drill bit to drill pilot holes wherever I was going to put something, and then I went through with the bigger drill bit to make sure they lined all up. You know, take your time. The things to think about with this is you want to make sure it looks nice, it looks balanced. Because people are going to see the outside, so you don't want things all crooked and everywhere. You want to lay it out to where it looks symmetrical. I think it makes it a little bit more professional looking. And so take your time, lay it out, and then I drilled the small holes and went and drilled the bigger ones. Now, one of the things also to consider is where you're going to mount everything. And as I was thinking about that, some people mount them at the top, some people mount them on the side, but I mounted everything at the top because all the wiring would be up at the top. And I think you want to think about how you're going to wire it. You want to keep your wiring nice and clean when you go to do that. And I think it just makes it easier with everything at the top. Plus, what it does is it's going to give me room down here in the bottom to store stuff. So here's, I'll store the inverter in here. This here, I'll end up mounting it somewhere, but this is the 30 amp master breaker, and this here is the solar charge controller that I'll mount. And I'll mount them to this. One thing I did is this here is a piece of old whiteboard, and I use that to kind of make a floor here. Now your battery being your heaviest piece in this whole component, you might want to center it in the box so that when you carry it, it will be balanced. It won't be leaning one way or the other and stuff like that, and it'll be more stable. I just took a couple pieces of wood, cut them to length, and hot glued them in, and that keeps it from moving this way. It's a tight fit this way, and move it. And I'll probably put some Velcro on the back side so that the battery will stick and stay down, so if it does tip over sideways, it won't fall. But that'll be like that. And then this here will fit right in, and we'll mount the pieces there. Now on the top, this is what it looks like on the back side. Here is the fuse box that will wire everything to, and all the switches all lined up, and the meter up here. You can see the meter here. I did put some hot glue around there to kind of keep it in place. I had to cut, obviously that's a square hole. I had to use, I drilled it out, and I tried to clean it up, the edges with a Dremel, but the Dremel kept on grabbing. So you just got to go really slow. The lip on the back side, on the front side, is not very much larger than the size here. So I couldn't, you know, I had to be almost like a super tight fit. So this was a real tight fit. I wanted to make sure it looked clean on the other side. Then I glued it in, and that should hold it. So that's pretty much it at this point. I'm going to take this and go wire it all up. I'll run all the wiring here, and I'll wire it down in the batteries and to the switches, and that's pretty much going to be the last step that we have to do. So with that, oh, one last point. When you do mount switches, if you do mount them in the lid, you know, you're going to have supports. You want to make sure that you can get between the supports. Otherwise, your switch won't fit and you'll have a bad day. You have to buy a new box. All right, with that, that is where I'm at now. I'm going to go and wire it all up, and then we'll get back and talk to you then. All right, take care. See you in a second. All right, I finished up the wiring on this project, so it's essentially done. So for this last step, let me tell you what tools you're going to need to do this. So here you're going to need yourself some wire cutters, get yourself some wire strippers, and you'll need a crimping tool. With this, you're going to need some also various lengths of wire, black and red, and you're going to need some various connectors. This is a ring connector, but you'll need a blade connector, maybe a prong connector, different things. Also, it'd be helpful to have yourself a voltmeter. And since I used an Anderson power pole connector on this unit for the ham radio, I had to get a special crimping tool for it, and this is it here. Now, I thought maybe I could get by with just using this, but you know, I'm going to get tools to get my job done, and it's better for me. I'd rather get it done right the first time and be quick with it than to mess around. I don't need to go all MacGyver on how to crimp Anderson power pole connectors with like a matchstick or something. You know, just get the proper tools, do what you need to do to get your job done, make it easier on yourself. Okay, I mentioned about what I was going to use this for. It's important that you understand what your mission is for this piece of equipment, because you'll need to know two things. One, how much power you're going to be consuming, and how long do you want it to work. So that will help you size your battery. Also, you're going to know how much current you're going to draw. And the reason for that is because you got to know what size wire you're going to need. Now, I designed this for 30 amps. And with any run 4 foot or less, you can run 30 amps on 12 gauge wire. So that's what I used. Why is that important? That's important because just like your house, if you change out the circuit breaker and pull more electricity in a particular room, you can start a fire. If you pull too many amps on the wrong size wire, it'll get very hot and it will melt the insulation and start a fire. So it's really important that you use the right size wire. And when you know the right size wire, then you know what size connectors to get. Okay, so let me open this up. Again, remember I put everything in the lid. This here would help make the wiring a little bit easier. And we can see here how it's all put together there. And then it gives me ample room in the back side here to be able to put you know, my inverter and other cables that I'm going to need. So let's talk about how the wiring goes. So from underneath in the battery on the positive side, the wire comes up through here and goes into this main breaker of 30 amps. So this will trigger, if I pull more than 30 amps, this is going to blow, protect the whole system. Then it comes up here and goes into this switch, and then the other side of the switch comes out, comes down and goes into the positive side of the battery input on the charge controller. On the negative side of the battery that's underneath, the wire comes through a shunt that's underneath that is used in conjunction with this meter to give you data. It comes through that shunt, comes back up, and goes into the negative side of the battery on the charge controller. Now on this load side of the charge controller, the positive and negative come out and run up here to the positive and the negative side of the fuse block. And then from there, you just jump from each circuit that you're going to use a power to your switch and then to your outlet. And here it's going to a power here to a switch. Same thing over here, comes up, goes in. So then you just fuse them appropriately. So for example, this outlet and this outlet is my USB outlet. And that's here, and I put in 5 amp fuses here. So this here can handle up to, I think, 60 amps, more than enough, so this won't be a problem. In case I blew up more, one of these plugs pulled more for whatever reason, shorted out, this fuse would blow. Okay, protect my device. It's important that you do that. Save your devices and save your work here. As far as the wiring, just make sure you leave yourself enough slack in here so that when it's fully open, it won't put any strain on anything. take your time wiring it together. First thing I did is I jumped all the negative sides together, tied it to the negative side. Same thing here, tied it to the negative bus bar. And then just ran wires from here to the switch and then to here. Just take your time, make it neat, use zip ties, tie and tuck everything together so it's nice and easy. Make sure you have enough slack. Come here, clean it up, make your wires as short as possible and condensed. And that's about it. Let me fire it up here for a second. Turn this on, the switch will take a second to load up because that charge controller is checking the battery to see if it's okay. If it wasn't okay, it wouldn't fire up. Okay, this here is the meter. Let's see how the light goes off, you can see it a little bit better. And you can see that it's roughly 12.6, that looks like 12.68 volts, and it's pulling about 20 milliamps. So power is being consumed right now. It's 100% charged, and I got it set for 11 amp hours. The battery's 22, but I cut it in half as being my gauge, because I only want to use half the battery. Okay, with that. And if you open this up now, open it up on the inside, you can see the charge controller here is working. You got the battery in the middle, and then you got a little arrow, and it's kind of hard to see, but there's a little light bulb. That's the load side. So that means it's switch on and off. Now what will happen is this charge controller, when you turn it on, like I said, it will check the state of your battery. If your battery is within the settings that you set on this, it will then, and it's okay, it will turn on the load side and power it. If for whatever reason this becomes overcharged, okay, or over discharged, it hits those settings, it's going to trigger this and it's going to turn this off. It's kind of hard to see, but you can manually turn it on. I don't know if you can sort of see that. It's kind of hard with the light. The little arrow went away. There, the arrow's away. Now if I can then turn it back on, you can see that the arrow is going to be back there. Give it a sec for the do it. There you go. See? So that means load is going to the side, but you can manually turn it on and off. But this charge controller will do that. That will protect your battery. You take good care of your battery's going to last a long time. Okay, one thing in this project I had to call an audible on, and that's for the charge side of the solar panel, which will take solar panel input or something from a wall. I went with this plug here. This is a SAE, it's kind of hard to see it there, but an SAE panel mount switch. I was going to use that little barrel connector, but I think that was going to be too much of a hassle and it would be harder to plug in. I thought it'd be flimsy, and I didn't want to mess around with that. So it'll be easier, just drill the hole and it mounted in there. I think I could have got that a little cheaper somewhere else. Got through Amazon. It was, I think, it could be a bit expensive, but it was the last piece I wanted to get this project done. Okay, and with that, let's go look at some solar. I'll show you this on the solar charger. Okay, I'm out here. Wanted to show a little bit about how the solar's working on this. Here's my panel. It's a 65 watt panel, foldable. I showed you that, and here's the gear. So I got this turned on. This won't charge unless it's turned on. And if you look inside there, let me get around this way. You see it's at 13 volts, and you see the solar panel is blinking, passing in, and it's providing a load, obviously, because it's turned on. So it's at 13 volts right now going into the system. Here shows the meter. Let me get it on there a little bit better, and hopefully it'll stutter. So this is telling you, I don't know if you can read it well, but this is telling you a percent charge that this has been charging. How much? There's 47 amps going right here. This shows here 13.11 volts. That's the voltage, or 13.1 volts. That's the volts of the battery. So you notice the other one said 13. So it's, it's roughly close. This is taking in 19, can't tell if that's watts or volts, but it's 1 point, it's probably watts, 1.4 amps it's pulling in. And how I do that on this meter, press and hold the top one. This shows the regular meter, is what it is. Okay, how many amps it's pulling, how much power you have left in the battery. So if I hold on this second or this bottom arrow, it goes to the charging. This is probably thinking a cumulative milliamps of how much has gone in. There's no documentation on this meter. I'm not too sure if you're going to be able to get it anyways. I think they've discontinued them. In any case, I wanted to show you how this works from a charging perspective. And I just set it up in the back bed of my pickup here, just charging. And here's the cable here, plugs into the barrel connector DC out. It's also got a USB there to charge if I wanted. I'll get a longer cord to make an extension cord so I won't be just so tied close to this. Make sure I get good sun. Anyways, that's the charging. So pretty happy with how it's working. Okay, I just wanted to quickly show some things plugged in to show you that things are working. Here I got a USB plugged into this iPad mini here. I use this for flying my drones, as well as a GoPro battery here. My GoPro here's plugged into the batteries for my drone. And show you that the batteries are charging up. See how they're blinking? And it's all working there. And it looks like if you look at the meter there, it's roughly anywhere from, I see it bounce from 1.5 up to 4 amps being pulled. So anyways, that right there is my little setup, and that's how it's working. Well, YouTubers, that's it. That's my mini solar generator project. I hope you enjoyed it. I hope I shed some light on things for you. I hope if you are thinking about doing it yourself, that this gives you some encouragement to give it a try. It's a very easy project. I think if you have all the parts that you need, it take you less than a day. It'd take you a day at the most. And you don't really have to have a ton of knowledge, some basic wiring knowledge, which hopefully you can get, and you can find any of that information on YouTube already. But this is a great project to do if you're inclined to do so. Hopefully this encouraged you. Thank you for watching. If you like what I put together and you feel like you'd like to, please subscribe, set your alert wherever that is on the screen, and to let you know about any other crazy things I might put together and put on my channel. So again, thank you for stopping by and thank you for watching. And with that, farewell.